So student, in the supervised learning, whatever we have seen, those are important points. But today we will see the introduction to support vector machine. Support vector machine itself is a supervised learning algorithm. So in the supervised learning, so far we have seen the regression. In the regression, we have seen the linear regression, polynomial regression, multiple linear regression. And in the case of the classification parts, we have seen what is meant by the logical regression we have seen. So all the theoretical point, numerical point, and practical points we have already seen. Along with these points, we have also seen the descent tree, and we have also seen the neural network. So in the supervised learning, we have a classification. Regression we have covered almost. But when talking about the this classification, so in the classification we are not having the one or two algorithm. We have a many algorithm. So support vector machine is the most important point. So in today's lecture, I will like to explain everything with the help of the images rather than the theoretical portion. So introduction to support vector machine I'm speaking over here. So it means today we have introductions only, and a remaining part of the support vector machine we will see in detailed manner in the next class. But today we have to understand what is the actual support vector machine and what is the functionality of the support vector machine in form of the classification. Let me move to the next slide, and that is saying to us points which are required to be discussed over here today. So we have three questions today's class. One, why support vector machine? Next, what is the support vector machine? And third, understanding support vector machine. So let me start the what is the support vector machine and why support vector machine and understanding support vector machine. So first, let me opt to the first question, that is why support vector machine. So in this case, we will listen a small story by which we need to understand how support vector machine is more applicable. So that defines the what is the need of the support vector machine in this question. So let me move to the this part right now. So in this slide, you can see we have three different flavors of the machine learning. Those are recognized by the supervised learning, unsupervised learning, and reinforcement learning. In the machine learning, we have seen the regression, linear, multiple, polynomial, logistic, decision tree, and neural network as well. So in the supervised learning, we have one more important algorithm that is come into the classification. So we have support vector machine. We were not talking about right now, and we are not talking about right now the unsupervised learning and reinforcement learning. So let us discuss the supervised learning in detailed manner more along with the one more algorithm, that is a support vector machine. So now this is the point. Supervised learning is saying to us what is the meaning of the supervised learning. Actually, this is a big question we must have. What is the supervised learning? So as from the various algorithms we have seen what is a supervised learning. So you can easily check machine learning models learn from the past input data and make future prediction as output, and that is the meaning of the machine supervised learning in the machine learning we have seen. So suppose we have a data set or we have a lots of data. So first, what is our responsibility? We have to train our model. So model can be trained by the training data. And what is the next step? We have to do predict. So if model is trained perfectly, then I have to put the new input to the my new model or newly designed model. So if I'm giving the new data to the my newly designed model, and that is the machine model, or that is also known as the machine learning model based on the upper algorithmic approaches. So what is the prediction I'm getting? That is to be done by the what is the accuracy I'm getting? What is the did input? What is the output I'm getting after giving the input? So if my prediction is correct, it means I am getting the good accuracy. But my prediction is wrong, or my prediction is not towards my desired result, then my model was not built properly. So from this perspective, from this concept, we have to understand what is supervised learning and what is the functionalities we have seen so far in the previous classes. So this is the most important terms we have to keep in mind. So that's why we have introduced these terms over here. Now, in this machine learning, definitely we have to touch some basic parts. So supervised learning algorithm, we have seen the two parts. One is the regression and classification. So when we have the classification, then we have to use the categorical nature of the data. But when talking about the regression, then we have to data nature that is a continuous nature data. So support vector machine is basically what that is mostly used in the classification problem. I'm speaking once again. Support vector machine is mostly used in the classification problem, but it is also supported by the two approaches, one is regression and classification. So it depends on the data type, it depends on the problem. Unlike dysentery, we can also use a support vector machine in form of the classification and regression. But I suggest to the people, just keep in mind mostly, or we can say the maximum time we will spend support vector machine to classify the data. So that's why the classes in the under the classification, this algorithm is categorized. If you remember the my one example or one PPT in the previous lectures, I have already shown an image in which SVM was undercome into the classification. So that is the beauty, that is the nature of the data type what we are using. So definitely we will use a data type or data nature in form of the categorical data. So support vector machine is mostly used in the classification problem. That is the point you have to keep in mind. Now, do not touch the unsupervised learning, reinforcement learning so far. Just we have to understand only the support vector machine. So this slide is telling to us where the support vector machine is lying. That is the point. Now we have to start this question, why a support vector machine? So before starting the support vector machine, what we have seen so far, we have covered where support vector machine is lying. So before moving to this question, just can anyone tell me right now, any doubt so far you have, or you need to ask many questions, so you can ask. Is it clear to all right now? Is it fine?
Yes, sir.
Okay, great. So now we have a big question. Sir, why support vector machine? Because support vector machine is a part of the classification as you told me. But why support vector machine? This is the kind of question you must have in your mind. To clarify this answer, I have some basic story, and that is more needed. So last week, my son and I visited a fruit shop. Okay. So if I'm visiting this shop, then what happened? My son is asking me questions that is that an apple or a strawberry? Because he found a fruit shop in which there are some similar type of the fruits are available. Just like the apple and strawberry look like the same. So we have a good size of the strawberry and good size of the apple. Then he will not able to recognize properly. So definitely he will ask me the questions that father, it is an apple or strawberry. So this is a big question I have in my mind. What he is asking, because I did not train to him, so he will not able to recognize this is an apple or this is strawberry. That is reason only. So he is not able to classify the fruits properly. So that is the point. So this is the big question I must have. But after training to him, after providing the better training, or after the couple of seconds, if he was trained perfectly, and there are two cases, he may train or he may not train. Suppose he was trained, but after the couple of seconds, he can easily recognize this is an apple, or this is strawberry. So he is recognized this is strawberry. Why? Based on its color. So, but apple color is also having the red color, and strawberry color also having the red color. So how he is recognized? He recognized the such fruit in form of the shape pattern. So based on the shape of pattern or shape features, he recognized this is a strawberry. That is the point. So I was happy at least he easily recognized or he classified the such fruit into the strawberry group or strawberry class. That is the point. From this point, we have many questions, but let us move to the next slide, which describes everything. So why I should not build a model which can predict the unknown data? That is the big point. So in the machine learning, what we are doing, if we are trained our model, we are feeding the any input that could be existing data or that could be new data. So my model should be trained and my model should recognize the particular fruit properly. Is this true fruit or it is apple or is it strawberry? So this is a big question I have in my mind, why I should not build a model that can be predict the unknown data. So as a basic machine learning approaches I'm using, so from the basic machine learning process, I have the two data, that is the past label data or label data. Why label data? Because in the supervised learning, we can use only the label data. That is the term you have to keep in mind. So past label data I have in the two form. One is a strawberry and apple. So my model will be trained over here. So after training my model, and I need to build my model, and definitely followed by some algorithmic steps. After applying the machine learning algorithm, my model was built perfectly, and I'm just inserting the black color strawberry. Suppose that I'm inserting the black color strawberry. So my prediction will be wrong or my prediction will be right. If my prediction is wrong, so I'm using the color feature. But if I'm using the color feature, that this could be the apple. So at the time, my model was not trained perfectly. So that is the only reason. So what I'm doing, I'm using the shape feature by which I can easily recognize this is a strawberry. So my prediction can be done correctness or correctly based on the shape feature. That is the point you people are required to understand over here. So testing data or existing data I'm inserting, I'm using over here in form of the new data. So prediction will be correct in two ways. One is a wrong prediction or right prediction. If it is being the right prediction, if I'm inserting the black color as a strawberry, definitely should not be. So how it is recognized based on the shape feature. But if it is not recognized, then what happened? It is following the different color, different kind of the features. So my model was not trained perfectly. That was the reason. But finally, I got the output that is it is a strawberry. So this is what this is a my model, which my model was built perfectly. So inspired from the machine learning process, I have this steps which defines that why I should not a model and that predict the unknown data. So from this point, from this story, we have a support vector machine to classify the my data in easiness. That is a point you people are required to understand over here. Now it is clear to right now. Slide by slide I will ask, but whenever you have any problem, so you can ask me. Now it is clear to right now.
Yes, sir.
Okay, good. So this is support vector machine. So this is a support vector machine. The person is telling me, but this is a big question I have in my mind. This is the diagram of the machine learning process. Is this a support vector machine? Yes, of course, because any algorithm of the machine learning will follow the machine learning process. So this is the process of the machine learning steps we are using over here. So definitely any algorithm we are using that is supported by the machine learning approaches, that will be followed by the machine learning process. So this is not a support vector machine. This is a support vector machine. We can't say right now, but this is a question we should have in our mind. Is this a support vector machine? So I have already written over here. So from this point, we have to start the point. So what is a support vector machine? So the meaning of the support vector machine I have over here. Support vector machine. We have a three beautiful terms: support, vector, and machine. And why support vector we have? Why is the machine we have these terms? So I will tell you later on, but let me just start the preface of the support vector machine before discussing its meaning and its sense. Let me give some preface of meaning of the support vector machine over here. So support vector machine is a supervised learning method that looks at data and sort it into one of the two categories. Two categories means we can classify we can make a group of our data based on its features. So if we have a class in which we have some students sitting over here, so how I can identify who is girl, who is boy based on the gender. So definitely what is gender? Gender features, we can distinguish these two classes. That is the point. So support vector machine is a supervised learning method and that is used to make the class properly to classify the data. That is the meaning. So from this slide, we have this meaning of the support vector machine over here. Now, this is a big question. I have written everything over here for your betterment or for notes purpose. So this is big question we have. How does the prediction work? So far in the regression and the linear, multiple, polynomial, logistic regression, descent tree. But this was the big question, how the prediction will work. In the support vector machine, you can apply the algorithm, and then what you will do, you can just determine this particular newly inserted data belong to this class or that class. But this is a big question a user or person must ask, or as a machine learner, I must ask this question: how the prediction will work? Because what we are looking at the training data, we are looking at the testing data. We are looking at the building the model. But after all these approach, we have big question at the prediction step, how the prediction will be done. That is a big question. So in the machine learning prediction is a step to predict the new data, but how does the prediction work? That is a big point, a big question we must have. So how the prediction will work and how prediction work, it is determined by the support vector machine, and that is the beauty of the support vector machine. That's why we are learning to understand what is the support vector machine. So support vector machine algorithm will determine or define the everything properly, and it is also telling to us how you can predict the newly inserted data. That is the beauty of the support vector machine. So how does the support vector machine work? It is different, but how the prediction will work. So that is the part of the support vector machine algorithmic steps. So let us move to the next slide, which describe the new part. So traditional figure of the machine learning process, we have the past level data, machine model train, we are doing prediction and output data. But in the support vector machine, what we have? In support vector machine, you can see we have two classes. One is the apple classes and the strawberry classes. So just look at the bottom diagram where we have some sample data, that is label data, of course, that is the apple data and strawberry data. So having seen these two different kind of the groups, I can use a line to distinguish this is the strawberry class, or that part belongs to strawberry class, and that part belongs to the apple class. So whatever line I'm using, that is known as the descent boundary. So please keep in mind this is a descent boundary. Suppose two group of the students are sitting in my class. On the left side, students belong to the boys category, and the right side category students belong to the girls category, or we can say the female category. So what is happening over here? The virtual line, I'm just predicting, I'm just assuming there is a virtual line between the boys and girls, and that is boundary, and that defines the descent boundary. So we can easily classify that point. So level sample data we have, so we can have the n number of the level sample data, and support vector machine will use some specific terms to classify the data. So here we have the two groups, so apple groups and strawberry group. So I'm using the descent boundary. Now after using the descent boundary, now student can insert the some new data. Suppose I'm inserting the black color apple, or strawberry color, or white or green color apple, or different color of apple, I don't know. So I'm just inserting the apple. I'm just giving the new data of the strawberry as well. So this data will be unlabeled because we don't know what they belong to. That is the point. As an initial label, what the data, what is the category of the data they belong, we don't know. So data classification we don't know, but after putting our model, after putting these data into our model will be used to determine that is machine learning model. Model will be used to determine in which class such apple belong to or the strawberry belong to the. So a newly inserted strawberry cannot be categorized into the apple class, or cannot come into the apple group or class. Same thing will be happen with the apple. So this is our support vector machine. So in the support vector machine, it seems to us very easy. Just use the descent boundary, we can distinguish. But actually, it is not happening. We have a basic and detailed step-by-step steps which describe everything. So it seems to us it is very easy steps, but it is not easy steps. So new data will be classified based on the features. And what is the feature I'm using right now? Based on the shape of the object. That is the point. So based on the shape of the object, newly inserted strawberry come into the strawberry class, while newly inserted apple will come into the apple class. That is the point you people are required to understand. So this is the point which seems us it is very easy step, but actually it is not an easy step. Starting from the support vector machine as initial level to the last level, we are looking at the output. It is following by some steps and some technical terms, some aspects by which our output will be predicted, or our information will be predicted properly. So this seems us simple, but overall this will be the steps. I'm speaking once again. Support vector machine will use a distance boundary to separate or to classify the data into more than two parts. So that is the point you have to understand properly. So it seems us very simple step, but it is not so because we have everything. So in the case of the what is the support vector machine, I will tell you later on. But why support vector machine? That is a big question. Why support vector machine? And they define the need of support vector machine. So need of support vector machine meaning we have over here. We have to classify the data into the two different groups. So we can distinguish if new insert data we are inserting or new object we are inserting, in which group the newly inserted data belong to. So that is the need of the important point over here. So before moving to the what is a support vector machine, we have a big steps. So can anyone tell me right now? Any doubt so far you have?
No, sir.
So the pictorial representation I'm taking over here. So everything is clear to all. That's great. So far we have been observed that support vector machine is used to classify the data into two groups based on the object and data features. Okay, this is the point, and that defines the why support vector machine, and it is also defining the need of the support vector machine. Let's move to the next point. Let us move to the next point. What is the next point? What is a support vector machine? So what is a support vector machine? We have the important terms over here. That is the example. So with help of the example, you people can easily recognize what is the actual support vector machine. So here I am taking the simple example in which I am taking the two different features. One is a height and other one is a weight. So we have a set of the people which is following by the features. What are the two features? Height and weight. See, here I have the sample data set of the female. So height of the female person and weight of the female person, I have the entire detail over here, and I have the sample data set of the male category. So height and weight of the both data I have over here. Now, what I'm doing right now, I'm classifying my data based on the gender feature. So male data and female data I have the over here. But I've composed both data, so I have the population. This is known as the population. But here I'm representing the divided data or separate data that is intercome into the sample data. Now, so use this diagram to let us understand some important terms. Everything will be in the form of the image. Whenever you feel any problem, so please let me know right now. Okay. So now you can see. Now I've zoomed this image, so now everything will be clear perfectly. So based on the given data, I am plotting my data points in form of some images over the graph, following by the two features. One is the height and weight respectively. So we have two groups. One is a group of the female and group of the male. So these data points are plotted on our graph in form of the images over only. So you can see we have a female group and we have a male group. Now it is clear to right now. It is visible to all right now.
Yes, sir.
Okay. What is the So what is the question we have? We have a big question. Let's add a new data point and figure out if it is a male or female. So suppose in this diagram, I'm just plotting the random data and we need to determine is it female or it is male. Do not think about right now the image, just I have inserted. Suppose I'm inserting the new data. So let me know right now, is it male or it is female? This is the big question we should have. So this is what we have to follow the prediction. So if I need to predict my model, based on the new data, so if I'm inserting the new data on the random position, suppose on the random position or based on the height, given the height and weight. So this is the big question we have over here. Is this male or female? So this is the prediction work. So SVM, that is support vector machine, will determine everything based on the prediction approaches. So now we have this point right now. So what I have written over here, let's add a new data point and figure out it is a male or female. So let us move to the next slide. So new data I have plotted over here. I can zoom it once again, and now you can see new data plotted on the random position, or you can take the input height and width. So I have plotted this position. So now do not think about right now this is a male or this is a female. This is only the an image I have plotted over here. So this new data is plotted on this point right now. So this is again we have a question how we can distinguish this is a male or this is a female. So for this understanding, for this purpose, we have some technical terms. Sure. For this task, we need to split our data first. Now, we can divide our data in two parts. I can use the line, and the support vector machine use a hyperplane or line to distinguish your data or split our data. So you can see, observe over here. Now you can easily see if I'm using the line one, then if I'm using the line one, then my newly inserted data will be the part of the male group. If I'm using line 2, you can see that is a green color line. If I'm using this one, that defines the my newly inserted data is the female group. Is it true?
Yes, sir.
And so can anyone tell me right now which line I must choose? Can anyone tell me right now which line I must choose? Just line 1 or line 2? And why? This is a big question. Can anyone tell me right now why I must choose a line 1 or line 2? Any specific reason? So please tell me right now. Just think and tell me right now.
Sir,
So
I think
line
line.
one.
Okay, if I choosing the line 1, so why line 1?
So it is
Sir, if
properly giving difference between the males and the female. So line one should be.
Or and if I choosing the line 2, why I'm not choosing line 2?
It's also including male in that.
No, don't think. See, do not think about the image only. This is only the data. So
Like
how
it
you
will give the
can?
proper classification line one.
So what is?
More optimal.
Okay, so you are on the right point right now. Just this some things are required to brush up. So line one you are choosing. So what is the reason? So we have a line one is optimal line. So that is a big question we should have in our mind. Line one is optimal line, but how this line one is a optimal line? That is is an optimal line. That is a big question. So let us move to the next slide and everything will be here. So we can split our data by choosing the appropriate line. So we can say line 1, line 2, and rather than the line 1, line 2, we can have the many lines. We can also have the n number of the lines. But which line you are choosing, that is more important. So this is a big question. So what is the big question? Which line is the best to split the data? I have already written over here. So what to predict the gender of the new input data point, we should display data in the best possible way. So you are saying me, sir, line 1 we should choose, or line 2 why? So there is specific reason, the technical term we have to use properly. So we have to understand this part properly in the SVM. So SVM, this is what support vector machine. So step by step I will tell you, but this is the first point we have to understand. If I'm categorize my data into the two way by choosing the appropriate lines, but why I'm saying this line is better than the other lines, that is a big question. So to understand this point, we have to move to the next slide. Now, is it clear to right now? What is the next question we should have in our mind? Which line is better? You are telling me this is optimal line. So why this is optimal line? So there is specific reason. So before moving to the next slide, do you have anyone who have any doubt or who is feeling any kind of the problem over here? So please let me know right now. Or is it fine? Or is it clear to all? Or any doubt so far? So please let me know right now.
It is clear, sir.
Okay, so now we have a second question that is a big question. Why this line is best if I'm choosing line 1? If I'm choosing line 2, why it is not best? So that is the only reason. See, just move to the next slide. Then I would say this line best fit the data. So what do you say this is the best fit line? That is a big question, as I told you. This is a this is some technical term we have to use. Baseline selection will be based on the maximum space. And what is maximum space? So parallelly, I have plotted the or drawn the dotted line on the graph along with the line followed by the along with the line one. So perpendicular, I am just plotting this two dotted line. These two dotted line will be close to the one data point of the male group and one data point of the female group. So this line has the maximum space that separates the two classes. I'm speaking once again. This line, that is line 1, has the maximum space. So what is the maximum space? You can see over the screen the differences between the data object on the one class or another class we have, that is the gap we are finding. So this is the maximum space, and this line has the maximum space that separate the two classes. So baseline selection will be done based on the maximum space. That is a tricky point you have to understand. Now, is it clear to right now? Step by step I will ask. Is it clear?
Yes. Yes, sir.
Yeah, if I'm choosing the line 2, so line 2 does not have the maximum space. If I compare the maximum space value of the line 2 by the line 1, so line 1 will keep the maximum space rather than the line 2 maximum space. That is the reason we have to choose this point. So this is only the one reason that defines the why you are choosing the line 1. That is the point you people require to keep in mind. So maximum space is a technical term you have to understand properly. Now, line 2. Line 2 does not have the maximum space than the line 1. So while the other line does not have the maximum space that separate the two lines, two classes, so that's why line 2 will not be selected. So you can see observe over here. Now you can see observe over here. Maximum space of the line 2 is not maximum or more than the line 1 maximum space. That is only reason. So this point is clear right now. Why we have chosen the line 1? Now this is a point which is required to understand. Yes. Now, yes, okay, good. So that is the important point we have to understand why we have chosen the line 1, because only reason the maximum space we have between the two data objects we can easily check over here. After this point, now this is the line. So rather than the line 1, line 2, line 3, we can have the n number of lines, but we have to choose only the one line that defines the maximum space. So we will choose the such line only. So now after understanding this point, let us move to the next step. In the next steps, we have the support vectors. So what is support vectors? Support vector means data points, the objects that are plotted on the graph. And we will consider only the support vectors. See, over the graph we have many data points, but some of the data points are closest to the our hyperplane or line. That is line 1. Line 1 is our hyperplane, or that is also known as the line. So some data points which are closest to the hyperplane, only those data points will be considered to the support vector in the support vector machine algorithm. As a mathematics I am speaking over here. Now, is it clear to right now what is support vectors? Now it is clear.
Yes, sir.
So that's why I have already drawn this example support vector. So some data points are close. So in the circle, this data point is close to the hyperplane. So such data points are considered into the support vector. And this could be one, or this could be more than one data points. Okay, so you can say n number of the data points and n number of the support vectors could be from the n number of the support vectors. That is a point you people have to keep in mind. Now hyperplane. Hyperplane is a line that is the best or optimum line which is used to separate or distinguish your two classes. And the above diagram we have this point. Now margin. Margin is basically the determine the space between the two data object and what is the maximum space we have calculated. That is more important. So when we have the maximum space in good volume, so that's why we have the large margin, or we have the good space, and such margin is known as the good margin. But when we have the small margin, so we are not easy to determine is it this is a data points we are known as the support vector, or is it not into the support vector part. So we cannot easily determine the classification of the data properly by choosing the small margin or minimum space. and such margin is known as the bad margin. So bad margin will provide the not easy to determine the classification, so it does not support the maximum space. That is the only reason. So margin means we are talking about the maximum space that should be good or maximum or more. Hyperplane is a line that is used to separate the work data or two classes we can say. And support vectors are the closest data point which are closest to the hyperplane, and these data points are under considered into the support vectors term. So these are the three important terms we have to keep in mind. Let us move to the some more technical terms. Into the next slide we will see. Okay, this is the example I have taken over here. This is the graphical way. In the animated way I have some image. These two images are determining that with this point is this slide. You can this slide. So I have already done support vector. So just look at the right side image in which some data points are closest to line, so they are just being as a support vector. And hyperplane will be our line. Okay, so that is used to separate our two classes. And the gap, what we are finding, the margin we are finding, so that is going to come into the maximum space, or that is also known as the margin. Same it is happening with the other image in the left side. You can see the red color dotted or green color dotted. So this image is basically defines the functionality of the support vector machines algorithm, and that is required. So then I would say the line is best line split the data properly. So line 1 I have chosen. Okay. Now it is clear so far. Everything is clear. Or anyone who need to ask the question?
It is clear, sir.
Okay, good.
Sir, the dotted line is known as margin.
This one. The dotted line. Yes, of course. This is determine the margin, and that is also known as the maximum space. Because you are determining the maximum space value by putting this dotted line. So the gap you are finding, that is going to come into the margin part. Yes, of course. If you have the large margin, it means you're talking about the maximum space. That is the only reason. So in the line 2, we don't have the maximum space. We don't have the large margin. We have the larger margin in the line 1 rather than the line 2. So that's why we are choosing this is our maximum space between the two classes. That is the only reason. But these two dotted line will be, or two dashed line, you can say, these two dashed line will be drawn perpendicular to the your main line, that is the hyperplane. Now clear right now?
Yes, sir.
Okay. Let us move to the important term. So we were on this slide where we have to add some more technical terms that defines into the support vector machine. So we have a distance margin. So some people are saying this is a margin, but I'm speaking this is a maximum space. So we have only the naming convention, nothing else especially on this. We have only naming convention. And some people are saying this is a line, but I'm speaking the hyperplane. So this is also having the same sense, only naming convention. And some people are saying this is a data point. So of course these data points are the closest to our line, so we can say these are our support vectors. So that's why we have a support vector machine. So an algorithm that is used to implement the machine learning algorithm or machine learning approaches by choosing the support vectors. So we have a new algorithm that is known as the support vector machine. So we can also say that the distance between the point and the line should be far as possible. So this should have the maximum space. So distance, margin, line, point, support vector, hyperplane, maximum space, these are the some technical terms you have to keep in mind. Now, these technical terms are clear to right now. What are the support vector? What are the hyperplane? What are the maximum space? Is it clear to all right now? Let me show them in the maximum mode, in the zoom mode. Now it is clear to all right now. Just tell me, anyone who need to ask any question?
No, sir.
Okay. So large margin or maximum space or good margin, we can say we have used. So in the technical term, we can say the distance between the support vector and hyperplane. I'm speaking once again. In technical term, we can say that the distance between the support vector and hyperplane should be as far as possible, as we have seen. So hyperplane VM and support vector VM. So we have some more two terms that require the define the D plus and D minus. I will tell you. So you can say the maximum space or the margin you are getting. So we are having a hyperplane in the middle point. So we can say, so the distance from the this hyperplane to the perpendicular dashed line, and we are getting the negative closest point or we are getting the positive closest point. So the distance from the negative closest point and positive closest point we are getting. So that is under come into the two new terms, that is the D plus and D negative. So this is the term. If I am adding these two terms, then I will get the value of the maximum space. Let me show. This one. So D plus is what? D plus is the shortest distance to the closest positive point. Now you can see distance. D plus is what? That is the shortest distance to the closest positive point. So from this point you can say what is the distance we are getting, that is shortest distance to the closest positive point we are getting. So that distance we can say this is D plus, and its negative point we can say the D minus is the shortest distance to the closest negative point we have, that is under come into the D negative. So you can see I have already underlined, I have highlighted some points. So you can say the D plus, and just let me zoom it first, then it will be clear to all. Yeah, it will be clear to more all the people. Yeah. Now, so D plus and D negative, you can see what is the D plus and what is the D negative. So from this point, this data, the distance we are getting from the actual data point to this new data point to the some support vector. So this will come into the shortest distance we are having. But in the case of this point, we are having the maximum distance. So the maximum distance we have, that is under come into the negative, or we can say negative closest point, and positive closest point will come into the shortest distance. So from this point, we have the two distance that is under come into the D plus or D negative. So practically or mathematically, if I add these two distances, then I will get the value of the maximum distance or maximum space. So that is the point you will keep in mind. So if I have already written over here maximum distance D plus and D negative, I can do. So see, maximum space equal to D plus D negative. So definitely this is what the distance between the closest data point, closest positive point and the closest negative point I am getting. So I am getting the exact value of the maximum space. That is the only point we have to understand. So this is a new technical term we have to keep in mind. Okay. Now, is it clear to all right now?
Yes, sir.
So I'm speaking once again, what is meaning by the margin, what is mean by the distance, what is mean by the maximum space, it is clear. Next we have the hyperplane line, we have cleared. Now we have cleared the D plus D negative, we have cleared. And now we got the other terms that defines everything properly, so that is support vectors. So what is support vectors, we have cleared. So these are the few technical terms we have to keep in mind while learning the support vector machine. So what you are observing, the prediction will choose the appropriate class by applying the various technical terms implicitly. So in the support vector machine, we have all these terms that define the how prediction work. So that is the beauty of the support vector machine algorithm. So it means line 1 was chosen at the baseline by using the maximum space, and this maximum space is known as the distance margin, and that's why now this line 1 is known as the optimal line, or this is also known as the optimal hyperplane. Okay, so this is the point you people require to keep in mind. So based on the hyperplane, we can say the new data point belong to the male gender. Based on the hyperplane, we can say the new data point belong to the male gender. Now it is clear to right now. Now we can separate. Now we can easily say. Now after this is the this hyperplane is also known as the distance boundary. In the previous example, we have seen while discussing the Y support vector machine. In that example, this hyperplane is also known as the descent boundary. So having seen this image, having seen this diagram, now it is clear to all the people. Now this newly inserted data will be the part of the mail group class. Now it is clear to right now. It is clear to all right now.
Yes, sir.
Okay, good. So now it is clear that optimal hyperplane line 1 we have chosen, so it is clear to us. Okay, good. But again, we have a question. So is there a guarantee every time the hyperplane we are choosing that is optimal? And there may be some cases when the hyperplane may not be optimal. Then what happened at a time? That is a big question. Is it true? Yes, of course, it is true. And that is a big question. Every time we are choosing the appropriate line that does not satisfy in the our criteria, if hyperplane is not optimal, all the hyperplane are not optimal, then what happens? That is the problem. So we will see this concept here only. With this point, we have a big mistakes. If you are not choosing the appropriate hyperplane, suppose if optimal hyperplane is not easily to detect in the my model or my problem, then if I'm choosing randomly random any hyperplane or line, then is there a guarantee my classification will be done properly? No. My classification enter come into the misclassification example. So not choosing the optimal hyperplane will make a big mistake. So your classification will not be properly, and that is a big problem. Okay, so this can be done by while choosing the low margins. That's why I'm speaking once again. Keeping the large margin is the best part rather than the keep choosing the low margin. Now, is it clear to right now?
Yes, sir.
So this is only reason we have to choose the low margins, because we will need to avoid the misclassification. So far, we have seen the SVM method that is used to predict our classification into the such right class, we can say. And that is the example of the LSVM. This LSVM is not known the low support vector machine. This is known as the Lagrangian support vector machine. I'm speaking once again. This is an example of the Lagrangian support vector machine, and this is the fast technique for training the support vector machine model based on the iterative process. And now you can say iterative process by, because for choosing the line 1, line 2, and so we have many lines. So iterative process we have to apply to get the maximum distance, as you have seen the animated images. So such SVM is undercome into the LSVM, that is known as the Lagrangian support vector machine, and that is a fast technique we have. So this is the point we have to understand. Now everything is clear, or anyone who need to ask the question right now? Yes, tell me right now. Any doubt so far, or everything is clear?
Yes, sir. Clear.
Okay, so far we have seen why support vector machine and what is a support vector machine, and now we need to look for the understanding support vector machine. Now, after understanding the why and what support vector machine, what is mean by the understanding support vector machine? Yes, that is also required, because these define the challenges. We can have the many challenges, issues. So how to resolve such issues and challenges? That is the important point we have to understand into the understanding support vector machine part. Now, let me just use the proper thing, so everything will be clear to all. You can easily see, observe over here, whatever we are putting over here, that is following by our sample data. So here we have some sample data which is depicted over our screen properly. But what you are observing, you can easily see over here. You can easily see, observe over here. We have the data two parts, but sample data we have. But we have data in normal form, no issue. No issue. But when we have the data in just like this way, just let me draw properly. This is the data. I'm using the highlighter. So we have this group of the data, one group. We have this set of the data over here. So we have this group, no issue. So we can say the dividation can be done easily. So that is under coming to the simple way. And some data, this is the data point which are closest to our hyperplane, and this is the data which are closest to the hyperplane. I am just marking into the circle way, and this is known as the support vectors. But the point we have observed over here, what is the point we can say? We can easily observe over here support vector machine we are applying, so we can easily distinguish. So this kind of sample data we are plotting on the graph, we can easily distinguish. There is no issue. But what is the problem when we have this kind of the problem, where we have this problem? When we have this kind of the problem, as you can see over the screen, if I'm choosing this line to separate my data, just I'm separating my data. Okay, this will be the one class, and this would be the one class. But here, what we are getting the mix of the data, mixed kind of the data. That is a big problem. So when we have the mixed kind of data, so our separation will not be done properly. Okay, no issue. So what we are doing by applying our another approach, we are choosing this kind of the classification. So what is the problem? If I'm putting into this all data in this group and in this group, so we have two groups. So what happened again? Here we have the mixed kind of the data. So separation or the classification will not be happen over here. So now what is the problem we are having? And this is under come into the linear data. This data is known as the linear data. This is known as the linear data. So what is this? This is the non-linear data. So when we have the data non-linear, so no issue at that time. But when we have the linear data, then we have a problem. So our data is represented by the one dimension, and this data on the left side, we are depicting data in the in the non-linear way, or we can say we can easily see into the form of the 2D manner. So what is the problem? Yes, problem is here we are not unable to apply the hyperplane. That is a point. So which line you want to choose? If you want to choose any line, then you can't distinguish your two separate data. That is big challenges, big problem we have to face. So to avoid such problem, we have a kernel function. Kernel function is used to transform one dimension data set into the another dimension data set. So we can easily apply the hyperplane to distinguish your data. That is the point you people are required to understand. I am speaking once again. The kernel function we have to use to transform your one dimension data set into two dimension data set. So you can apply the hyperplane, and vice versa is also applicable to the two dimension to three dimension. So two dimension data set is also having the properly, but we are unable to apply the hyperplane online. So what happened at that time? We have to transform two dimension data set into the four dimension data set, so we can easily apply the hyperplane. That is the point you people are required to understand. Let me show my proof. So here we can't use the hyperplane. That is a big problem. Here we can't choose the hyperplane. This is a big point. If I am choosing this one, separation cannot be done. If I am choosing this hyperplane, separation or classification cannot be done. So that is a big problem. So what we have? So it is necessary to move away from the one dimension view of the data into the two dimension view. So here we have a transformation. So transformation is known as a kernel function we have to use. So kernel function is used to transform linear data into the non-linear data. So we have to use a kernel function. And that is the beauty of the kernel function in the support vector machine we have to use. A student asked me question, sir, what is the mathematics formula by which we can do? So my dear student, I am not putting the hard mathematics formula over here. I'm just giving only the concept in which we have to understand what is the kernel function. So in the kernel function, we have a various variety. So if you're looking for the hard mathematics, so which mathematics will take many times or it will take much time, and some parts will be skipping the concept over your head. So to keep the concept in your mind, so I'm just not touching the hard mathematics. I'm just speaking the generalized way. Kernel function is a function that is used to transform one dimension data set into the another dimension data set. So you can understand the thing properly, or we can say it is used to transform linear data into the non-linear data. So our hyperplane can be introduced. That is a point you have to understand properly. So this is a kernel function. Now, in the Python programming, we have the kernel function and we have the various kind of the kernel function we will use. So we can apply the kernel function undoubtedly over here. So while doing the practical part of the support vector machine, we will see the how to change, how to use a various kind of kernel function. And that is the beauty of the Python programming. We have the many classes, we have the many libraries and many packages by which we can simulate our work in concise way, in the simple way. That is a point. So you can easily see we have the one input that is one dimension form, and we have the output in the two dimensions. So what we have been need to change. See what we have to do. We have to change this one into two dimension. That is the using by the kernel function. So what we have done, we have transformed. So now we got the result. So you can easily see, observe over here, I have already marked by properly. So these data points which are marked by the black circle, okay, just let me show the proof with the help of the zoom board. So the data points are the blue color and the yellow color data points are plotted close to the line, so that those data points are known as the support vector. And our line is passing or closing to the that data point, so these are intercoming to the classification point. So we have a hyperplane we have depicted over here. So now we can easily classify the data in simpler way. So now our equation that was a linear equation has been transformed to the non-linear equation. So we have equation y equal to x square only. So what happened? We have transformed one dimension data set into two dimension data set in form of the by the using the kernel function. The kernel function is more important. That is the point you have to understand. But every time it is not required. Whenever we are facing such problem, our data points are depicted on the screen or the graph in non-linear approaches or in form of the different way where the hyperplane cannot be acceptable. At a time, kernel function you have to apply. That is the point you have to understand. Now, next we have a problem. So you're talking me is a 2D. In the 2D dimension, we can also have the problem. So just look at this diagram. So hyperplane cannot be drawn. Hyperplane cannot be applied in this kind of the plotted data, because if I'm choosing any hyperplane, I have marked about 3 different hyperplanes. So if I'm choosing the 3 different hyperplane, if I'm choosing any one of the hyperplane, then what happened? Unable to distinguish, unable to represent the 2 different classes. Again, I have to apply the kernel function. So what it will do, it will transform my 2-dimension data set into the 3-dimension data set. Now let me show the proof. This is our example. This is our example. Now you can see the screen. So this was our 2-dimension data set. I'm just transformed into the 3-dimension data set. So now I have plotted the hyperplane. So after inserting the hyperplane, I can easily distinguish my data set into the 2 different classes, and that is a need of the support vector machine. Support vector machine is used to predict our 2 classes or to predict the new data into the correct class in accurate manner. And one more thing, and we can also use the hyperplane to represent the 1-dimension data set into another dimension data set to apply the hyperplane to distinguish the proper class. That is only meaning of the support vector machine we have seen today. Okay, is it clear to all right now? Is it clear to all right now? Any doubt so far? So please let me know right now. Is it clear?
Yes, sir, clear.
So as I'm speaking the summary part, what we have discussed the 3 important points. What is why support vector machine, and in this case we have the term need of the support vector machine. So we have seen. Next we have seen the what is the support vector machine. So in this case what we have seen, how the prediction will work inside the support vector machine. So that is the beauty of the support vector machine we have used. Next, we have to understand the support vector machine by applying the kernel function, because this is the phases and this is the issues and challenges we have to face. So that's why we must ready for this kind of situation. So we have divided our class today 3 parts. So we have seen the 3 different parts into a specific manner based on the step-by-step approaches. So this is just introduction of the support vector machine today we have seen. So if you have any doubts, so you can ask.